Okay, so yes, we are back here. Now remember, I want to go to the next one, but to this number 3a. But before I talk about it, there's something I just want to remind you. Why did we say that this was pent 3 in 1 ion, even though priority of the functional groups? You remember there's priority list. If you want to, you can go and check the video on the priority list of functional group. But I told you that for this one, just know that alkenes are higher on the order of priority, on the hierarchy, okay? They are higher on the hierarchy than alkynes. So we like to number and give the alkenes the lower number than the alkynes. But there's another rule which says the sum of locants. And that is when you have them, the one way hierarchy matters is like this one, where they are both on the same position. But when they are on different positions, you have to use the sum of locants. In other words, if I number like this, 1, 2, 3, 4, 5, the way I've numbered, 1 is 3, the other one is a 1, which if I add the 2, they give me a 4. But if I number like this, to say 1, 2, 3, 4, and 5, what is the lower number for the alkene is 2, and what will be the lower number for the alkyne? It's a 4. So it'll be 2 plus 4, which would give me a 6. So 6 is more than a 4, so I'll choose this one where 4 is. So it would have been the one which we have done, where they add up to 4, right? Exactly. So it's like we said, you just choose where the first functional group appears, okay? The lowest possible number for your functional group. So that is what it is like. Now let's go with that to do this next question, because this is again very important for us. Okay, I hope you understood. What rule did we use? We used the rule of the sum of locants, okay? Sum of locants. They should be the lowest possible sum, all right? So here 3 plus 1 gave us 4 instead of a 2 plus 4. Now we come here and we see we have this guy. It is 7 methyl nona 2,4-diene. Okay, so diene, or whatever you want to pronounce it as. This is 2 of the alkynes. Okay, when we have 2 alkynes, we say we have a diene, or diene, whatever. This is 2 alkynes, and we see one is on position 2, the other one on position 4, right? So we can look at this. This is the what do we say? This is our parent chain. It is nona 2,4-diene. So nona is for 9 carbons. So they said they want a structural formula. So our number 3a would be, we put 9 carbons, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then on position 2, we come to position 2, we put 3 things, and then we go to position 4. So this is 1, 2, 3, 4. On position 4, it's like this, okay? It'll be 4 and 5. 4 will be the lower number, that's why it's position 4. All right, so this would be what it's like. Here we have another triple bond. Here we have it. So this is going to be our nona 2,4-diene. Then we have a 7 methyl. So we have 1, 2, 3, 4, 5, 6, 7. On 7, we have a methyl, so we have another C here coming out like this. And we can start to put whatever the hydrogens we need. So here it's already 4 bonds. This carbon here is already 4 bonds. This carbon right here has 4 bonds. This carbon right here has 4 bonds, because it is 3 this way and 1 that way, makes it 4. But this one has 1, you should put 2, it's 2, you should put 2 more. This one here has 3, you should put 1 more, and it's always like this. So this is what we have. This is an H and an H and an H. This is an H and an H. Here we have again an H. Here we have an H. Here we have an H. Here we have an H and an H and an H. Then this C has 3, obviously. So it is like this. Okay, H, H, and H. This is your CH3. So this one I should make it come here so that this comes here. Okay. So this is how it is, and you would be done. So this is what you have, and this is going to be your nice, what is it? This is going to be your nice 7 methyl nona 2,4-diene. This is going to be the solution, and you're done. Now we want to go to this second one, and we see again the idea of the sum of locants. You will enjoy, okay? Goodbye for now. See you in the next video. Bye.